was involved in this in a lot of different ways, really right from the beginning. He's the author, as you know, of one of the best-selling high school biology textbooks. And it was his book that was being laced with Darwinism. I'm going to put that as a blurb on the next edition. So he's going to tell us today about his testimony on the scientific evidence.
I'm hoping I'm properly plugged into the PA system.
Yes.
Yes? Okay, very good. I entitled my talk Fossils, Genes, and Mousetraps, Making the 21st Century Case for Evolution. And there are a number of reasons for that, but I'm going to talk about fossils, I'm going to talk about genes, and as you will see, I will also end up talking about mousetraps. Just a little bit of background. I'm a cell biologist, not an evolutionary biologist. I work on biological membranes. I do a lot of structural biology and electron microscopy. One of the things that has drawn me into the evolution controversy is quite a few years ago, I began to write a series of textbooks which are widely used in high schools across the United States with a wonderful co-author named Joe Levine. Some of you may know these books. These are known by high school teachers in the US and Canada by the animals on their cover, the lioness book, the elephant book, and most recently the dragonfly book. And a few years ago, I hate to overplug these things, I wrote a book on evolution and religion, which Jamie Scott was kind enough to mention, called Finding Darwin's God. The Dover trial, I think, amplified interest in all things evolutionary, and my publisher has asked me to rewrite a new afterword for this book, and this will be reissued in a new edition in the next couple of months. And those of you who are interested in questions of evolution and religion might find this book, especially for a biologist, a good treatment that would complement the sort of wonderful stuff that Jack Hawk has written about theology and evolution. Now, the premise for everything we're doing here today is, I think, very simple. That is, we live in interesting times. You might say very interesting times. And you've already heard a few years ago that a county in Georgia, Cobb County, decided that the new biology books they had bought for their students were so dangerous that they needed a warning label on the inside of them. And of course, being public-spirited citizens, you'd like to know, gee, what book was that was so dangerous? So I figured I'd let you know. That was the book. There were several books, actually, that had bunch of stickers on them. This is how the sticker read. This textbook has material on evolution. Evolution is a theory, not a fact, regarding the origin of living things. This material should be approached with an open mind, studied carefully, and critically considered. And I remember when that disclaimer came out, I was called up by a reporter for the Atlanta Journal-Constitution. And she asked me, Dr. Miller, aren't you outraged about that sticker that they're putting on your textbooks? And I'd spoken to enough reporters to realize that what she was doing was trolling for a quote. And what she wanted to do was to write a story with a headline that says, author incensed, or author slams board, or even better, northern author criticizes the school board. And I decided I didn't really want to give her that satisfaction. So when I said, no, I like the disclaimer. She said, you do? I said, I think the disclaimer is great. My only problem with it is it doesn't go far enough. And she said, what do you mean? And I said, well, the book does have material on evolution. Back cover says Unit 5 Evolution, so kids don't need to be told that. Evolution is a theory. I've got a section of the book entitled Darwin's Theory of Evolution. Of course it's a theory. But when you say it's a theory, not a fact, that makes it sound, as you all realize, like theories and facts are opposite things. And they're not opposite things at all. The way I tried to explain them to her is, let's suppose the young person went to the University of Georgia and studied physics. Well, one of the courses they'd have to take would be a course in atomic theory. We're not going to change the name of that course anytime to atomic fact when we become really sure that atoms exist. That's not the point. Atomic theory is a system of explanations that unifies hundreds of thousands of experimental observations and facts. And that's exactly what evolutionary theory does. As my friend Jamie Scott is fond of saying, theories never become facts, theories explain facts. They are a higher level of understanding. But what I said the sentence I really object to is the third one. And she said, you mean you're against open-mindedness? And I said, no, don't understand. Read that like a 14-year-old. You know what that sentence says to a 14-year-old? It says we are certain of every single thing in this book except for one topic, and that is evolution. And I object to that not so much as an evolutionist, hell, I object to it as a cell biologist. Because what it tells students is you don't need an open mind to study cell biology. You don't need a critical analysis to do ecology. All this stuff is figured out. Evolution is the only thing you need an open mind for. It's nonsense. So I said, I tell you what I'll do. No charge. I'll rewrite the sticker for Cobb County and save a lot of trouble. And here's the wording that I suggested coming up on the screen now. This textbook has material on science. Science is built around theories which are strongly supported by factual evidence. Everything in science should be approached with an open mind, studied carefully and critically considered. Tragically, at least from my point of view, the board rejected my offer. They went to court, they had a trial, they lost. As Jeannie said, that verdict has been set aside. And for all I know, I'm going back down to Atlanta to testify in another trial. That's not impossible, although I hope the people in the board will see their senses. But in any event, the reason we're here today, also, as Rob alluded to, you might say was precipitated by our book. And what do I mean by precipitated by our book? Well, what happened several years ago was that teachers in the Dover area high school decided they'd like to have new biology textbooks. They looked around and they picked our book as the one they'd like to have for the students in Dover. And eventually they got it. But a few things happened on the way to the textbook purchase, as it turns out. And one of those things is a member of the Board of Education, William Buckingham, as any of you who have attended the earlier sessions in this symposium have heard, he read this book and he pronounced it from beginning to end, this book is laced with Darwinism. And as Rob said, we're going to put that in the back jacket of the exhibition. We think it will pump up sales. But in any event, this, in many respects, provided the opportunity for the activist members of the board to go ahead and push for this idea called intelligent design. And the morning after the Board of Education in Dover voted to implement the intelligent design policy, this was the scoreboard outside Dover High School. You're not making this stuff up. IT1, Darwin, nothing. And I looked at that when I saw that in the newspaper or the internet. I thought that was a lot of fun. But as an old baseball player, I realized it really doesn't hurt to let the other team get a little bit ahead, as long as you get to pile on at the bottom of the ninth. And lo and behold, we got to pile on at the bottom of the ninth. The offshoot of this has been very well described by earlier speakers in this symposium. Is the board implemented its intelligent design policy. The Dover teachers, to their everlasting credit, and they've been honored by the National Science Teachers Association for this, refused to read this statement or teach intelligent design. Administrators had to go in the classroom in this sort of curious ritual that Brian, I think, adequately and comically described, and go ahead and read this statement and say, there's no questions, see you later, while many of the teachers actually stood outside in the hallway. As a result, a lawsuit was filed. That lawsuit went to court. There were a whole series of expert witnesses who appeared in it. Rob Hicks, what Rob looked like on the trial with his obligatory coffee every morning at the beginning of the day. I had the honor, if you want to call it that, of being the lead witness in the trial for the plaintiffs. I figured this is going to be a cakewalk. I'd spend a day on the stand. The trial started on Monday. I'd spend a day on the stand. I'd present the case for evolution. I'd answer the questions from the other side. I'd go home, and a Thursday afternoon, I would lecture in my cell biology class back at Brown, because that's the course that I teach in the fall. Didn't work out that way. The cross-examination went on, and I had to spend the second day on the stand, which surprised me because I had hoped to be back to teach my class. In more than 25 years of college teaching, I've never had to cancel a scheduled lecture. So I had to figure out that night when I knew I'd be on the stand the next day what to do. I emailed all my students, I told them what I was doing. I didn't want them to think I was goofing off, so I sent them a link from the article in Science magazine that explained what the trial was about. I sent them a link to the story in the New York Times. I think they thought that was okay. You know, at least the professor wasn't off skiing, but they weren't really impressed until they saw that the trial was not just being covered in Science, and not just being covered in the New York Times, it was being covered in the ultimate news source. The ultimate news source, of course, being the Daily Show. And when they saw that, they realized, oh, this is good stuff. Now, after the trial ended, it got even weirder, because as it turns out, in January, this trial was also covered on the Colbert Report on Comedy Central, and believe it or not, I wound up as Stephen Colbert's guest on the Colbert Report on Comedy Central. And if any of you would like to see the video clip of that, I can play it afterwards in response to questions or something along that line if we have enough time. Suffice it to say, when I started to teach my really big course in the spring semester, which is a freshman intro bio course, I could have won the Nobel Prize between semesters. It wouldn't have impressed my students as much as being on the Colbert. But let's leave the ridiculous aside a little bit and get back to the sublime. As you all know, an extraordinary decision was handed down by Judge Jones just before Christmas 2005. It was as fine a present as anyone could have hoped for. And I don't know how many of you have downloaded and read this decision. It's 137 pages, but it is double-spaced. And I want to urge all of you, download it and read it for a couple of reasons. One is, this guy does not write in legalese. He wrote in plain English. This is actually understandable. The second thing is, it's funny. You should read his recounting of the antics in the courtroom. I learned about the decision. I was traveling back home. Warren called me up on a cell phone, tell me we not just won the case, but we hit a grand slam. And he said, I emailed you the decision. Can you read it? And I said, I'm on a train. He says, when you get back to your office, download it and do a search for the word liar. The word liar appears in the decision 3 times. So when you're done with that, then look for inanity. Don't expect to see this in court decisions. So at the very least, in addition to being the best compendium of arguments that demolish intelligent design that I've ever seen, this decision is downright entertaining, and you will enjoy reading it for a variety of reasons. So I urge you to. It's just called Kitz Miller, K-I-T-Z Miller versus Dover. If you Google on that, you'll find copies of all over the internet. It's very easy to get hold of, and I would urge you strongly to do it. Now, what actually happened in the trial? Because you heard a lot of perspectives today, but one of the perspectives you really haven't heard is how, within the confines of the trial, we tried to make the scientific case for evolution. There's an artifact of the way that federal trials are conducted that you might not have thought about, but we were all acutely aware of. And that is, the plaintiffs have to make their case first, to be followed by the defendants. And what that meant was that if we wanted to rebut arguments that we knew were coming from Michael Behe and Scott Minnick and other advocates of intelligent design, we, in effect, had to make those arguments to the judge first and then show what was wrong with them, because we were not going to be able to follow these individuals. We also had to prepare the attorneys to be able to cross-examine these witnesses on the basis of science. I thought this would be really easy to do. Then in April of 2005, I was at a meeting in Philadelphia. I went out to dinner with the attorneys who were handling the case, and at the end of it, I was despondent. They didn't know anything about biology. I thought, this is going to be awful. This is going to be terrifying. To our absolute amazement, and every one of the experts will tell you this, these attorneys were like your best. Here they come, sneaking in so they These guys were like your best grad students. They absorbed science like sponges dropped in water. It was absolutely extraordinary. And to read their cross-examinations of the witnesses for the other side is to read a masterpiece, not just of lawyering, but of genuine scientific understanding. So this was the key, and I have a couple of courtroom sketches up here. This is a sketch from NBC of my testimony on the first day, being cross-examined. Sort of realistic, although the attorneys were not that close to the bench. And here is a somewhat more impressionistic, but I think much better sketch of Eric Rothschild cross-examining Michael Behe that appeared in the marvelous article about this trial in the New Yorker that appeared in December of 2005. If you want to read anything about this trial, read the New Yorker article. It's even funnier than the judge's decision. And I think you'll enjoy it and enjoy it immensely. So what did we want to do? I think the first thing that we realized is we had to frame the case. In particular, we had to deal with this idea of intelligent design. If I had to give a gold medal to anybody in this so-called controversy, I would give it to the ID people for coming up with the phrase intelligent design. It is a brilliant piece of public relations mastery. There's a couple of reasons for that. One is, when you hear the word intelligent design, if you're a person who goes to church on Sunday and believes in God, you immediately think, hey, those are my guys. And the reason for that is theists, and I mean that broadly construed. People who believe in any sort of God think that there is an intelligent design to the universe, and that is the work of a creator. For what it's worth, that's what I believe too. But it turns out that in this context, that is not what is meant by intelligent design. What is meant by intelligent design is actually something very different. And that is that design, and design, as you'll see in a second, means direct, creative intervention, is required to account for the origins of living things. This means it's actually a doctrine of special creation. And in this respect, ID, as you heard over and over again today, is nothing more than creationism sanitized to appear scientific, and so as to sound non-religious. Now, the first time I brushed up against this movement, I scratched my head for weeks, asking myself, why do they keep saying design? Why is it design? Why not create? And I came to the conclusion that all these guys had been to a summer camp, a training session, where electric shocks were passing through their bodies every time they uttered the word creation. So finally they would just say design, 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 and they would never say the word creation. So for example, let's take this wonderful example they use all the time, and if you saw Flock of Dodos last night, you saw Mount Rushmore over and over and over again. Now, here's an interesting thing about Mount Rushmore, and that is, sure, it was designed. But how do we know that Mount Rushmore was designed? We know it was designed because it's there. Now, that's more important than you might think. The reason we know it's designed is because there's a material structure there. And the production of that material structure, the carving of Mount Rushmore, that was creation. That was, in fact, a creative act. That means a so-called designed object only exists for us to look at if it was also created. So it's disingenuous to say it was just designed. Now, the interesting thing about that is that this analysis applies to things like the bacterial flagellum as well. Saying it's designed is only part of the story. If it was just designed, it would be a sketch on the designer's blueprint. It had to be created, or we wouldn't have a physical object to look at. Now, let me try to drive this home, because this is a very important thing that many of our scientific colleagues miss. I want to show you the designer of Mount Rushmore, the sculptor Gutzon Bergman, and here he is working on his design. Now, that's not exactly what Mount Rushmore looks like. There's no hand coming out of Mount Rushmore, for example, but that was part of Borglum's original design. He was the designer. Now, the next question is, who created Mount Rushmore? Not Borglum, these guys. A team of more than 100 stone cutters and sculptors. Those are the guys who are the creators of Mount Rushmore. So the presence of a designed object actually implies dual acts of design and creation. And it's disingenuous to say it doesn't involve creation. Now, how does this apply to biology? It means every object, biochemical pathway, protein, or structure that is held up as an example of design, taking their theory at face value, had to be produced in an act of special creation. That means the Cambrian was a period of special creation. The eukaryotic psyllium was created. The initial arthropods were created. The bacterial flagellum was created. Now, believe it or not, Bill Dembski, the mathematician behind intelligent design, agrees with me on this point. And that is, he said, here's what happens. Designer conceives a plan. Then he forms a plan. He then specifies building and materials and assembly instructions. Finally, the designer or some surrogate applies those assembly instructions to building materials. That's called creation. In other words, intelligent design equals creationism. That doesn't mean it's wrong. It simply means this distinction isn't artificial. It is a very particular kind of creationism called special creationism, but it is creationism nonetheless. Now, case in point, all of the old anti-evolution arguments pop up again and again and again with respect to intelligent design. For example, case in point is that intelligent design repeats the old arguments we hear over and over again about the lack of intermediate forms in the fossil record. Way, way back in the early 1980s, I, in my callous youth, decided I would debate scientific creationists. And I debated people like Dwayne Gish and Henry Morris, and both of them were fond of showing slides like this, ridiculing the idea that cetaceans, swimming mammals like whales and dolphins, could have evolved from terrestrial animals like cows, for example. And Gish, in particular, had a very comical slide showing what he thought was an intermediate between a whale and a cow with a big udder down here and horns, the body of a whale, and saying this is absolutely absurd. And you might be interested to know, lest you think that's just an argument creationists use, but the leading lights of intelligent design have made the same argument. For example, Michael Behe in 1994 looked at this and said, if random evolution is true, I always love that term, random evolution, there must have been a large number of transitional forms between land animals and ancient whales. Where are they? In other words, we're missing the intermediate forms. Now, Mike has not spoken a lot about the missing intermediate forms in whales since paleontologists began to dig up fossils that look like this. This is a fossil of Pakicetus, one of the relatively recently discovered intermediate forms that illustrate basically how swimming mammals evolved from terrestrial ones. And if you follow this story closely, you know that we have not one, not two, not three, but by any fair standard, we have about 5 intermediate forms. And this is taken from Carl Zimmer's wonderful book on the evolution of whales and dolphins. So we now have a case closed in terms of doing this. Now when I speak to lay audiences, I try to emphasize how science works. And one of the things that I will say, does that mean that you guys, an evolutionary biologist, have now said, see, we got the intermediate forms, we don't have anything else to do, we've proven it? The answer is of course not. Science is enormously self-critical. And one of the things that the people who work on this fossil record have been critical about is this realistic? Are these guys really intermediates? For example, if any of you have been, and I know lots of you have been swimming or snorkeling, scuba diving under the water, you know that your hearing sucks underwater. Your hearing stinks. You can hear sounds, but you don't have much of a directional sense, not like we do up in the air. The reason for that, of course, is that the bones of our middle ear are adapted for hearing in the air. Whales and dolphins, on the other hand, have a rearranged structure of the middle ear bones, which is beautifully adapted for hearing underwater. Their hearing is so good that they can navigate in total darkness by using a form of sonar, so they're exceptional. If this is real, then the skulls of these intermediate species should show how the middle ear bones were rearranged in the process of evolution. It's a way to test the validity of this part of the fossil record. Well, lo and behold, 2 years ago in Nature, a series of scientists got these skulls and they CAT scanned them, basically, and they studied the rearrangements of the middle ear bones. And lo and behold, this fossil record has a complete record of how these bones were rearranged in a series of step-by-step intermediates, including true intermediate forms that were halfway adapted for hearing in air and halfway adapted for hearing in water. The fossil record fills in when we have the opportunity to discover the species that we know and we would predict by evolutionary means are there. Now, all of you know spectacular examples of this that have popped up just during the last couple of months. And I bring here an article in from April of this year from that noted left-wing propaganda rag, Wall Street Journal, describing 2 discoveries that, in the words of writer Sharon Begley, answer big questions in evolutionary theory. One of them was biochemical, and it actually answered the question of irreducible complexity. The more graphic one was the discovery of a spectacular new intermediate form in the Canadian Arctic, Brian, illustrating the evolution of the vertebrate, the tetrapod forelimb. And I think you all know about this discovery at this point. I was actually called up by a reporter, and the reporter said, isn't it great that they found this missing link? And I said, you have to appreciate the fact that in the fish to amphibian transition, we have so many intermediate forms already that this was hardly the case that was begging for one, but it just now we have more detail. And in the years to come, we will have more details still. But the notion, repeated over and over again, that the fossil record is devoid of transitional species is simply nonsense. And I think the best way to refute that is not by clamping down and saying, don't say that, but just by showing the evidence. And we now have abundant evidence in all sorts of animal groups with which to do this. Now, every now and then one of my colleagues says, you're not a paleontologist, you're not an evolutionist, why are you involved in this? Well, one of the reasons I'm involved in it is because an awful lot of the arguments that the intelligent design folks are making these days are biochemical and molecular and cell biological in nature. One of those, for example, is the claim that evolution cannot explain the origins of complex cellular machines. Now, why can't it explain it? That's because, according to the proponents of ID, these structures, here's the bacterial flagellum, for example, have a property called irreducible complexity. And that property means that these things couldn't have been produced by evolution, even in principle. Prime example, the bacterial flagellum. The bacterial flagellum was brought up so often in the Dover trial. I don't know how many of you know this. That Scott Biddick, one of the experts for the defense from the school board, got up, put up a slide of the bacterial flagellum. Judge Jones looked over that, and he deadpanned, we've seen that before. And Scott Biddick just shrugged, and he said, you know, Your Honor, I sort of feel like Zsa Zsa Gabor's fifth husband. I know what to do, I just don't know how to make it exciting. In a way, although he was on the other side, I thought it was the best line of the trial. This was such an overused example. It was just absolutely unbelievable. Now, what's the argument here? This is made, I think, eloquently by Michael Behe from Lehigh. An irreducibly complex system cannot be produced directly by numerous successive slight modifications. I want you to stop on those words because you've heard those words before. Numerous successive slight modifications. Those are Charles Darwin's words from The Origin of Species. And he uses them exactly. If you cannot produce it by modifications of a precursor system, and here's why. Any precursor to an irreducibly complex system that is missing a part is, by definition, non-functional. Now that, if it were true, would be an enormously powerful argument against evolution. Now, basically what Behe says is that the cell is filled with complex machines, structural and biochemical, and these machines are unevolvable because their individual component parts are absolutely useless until they are fully assembled. Now, there's a very important point to understand at the onset about this argument, and that is, this is not an argument for design. It's an argument against evolution. So there's nothing about irreducible complexity that implies design. It simply says, if these truly are irreducibly complex, according to the reasoning, they couldn't have evolved. So the desire is negate evolution, and design floats in as the default explanation. That's different from having evidence for design, and that's an important point to understand. Now, Dr. Behe is trying to explain this to lay people, and he says a good example of such a system is a mechanical mousetrap. Now, I know most of you lead such vermin-free lives that you've probably never seen a mousetrap, but I brought one along with me, and just like Behe says, it has 5 parts. It has a catch, a platform, spring, a hammer, and a little hold-down bar. You can't catch a mouse with a platform. Then you get a spring, catch a few more, and a holding bar. He's right about that. All the components have to be in place before any mice are caught. Thus, the mousetrap is irreducibly complex. So the machinery of the cell, just like a mousetrap, is irreducibly complex. Now, let's think about that for a second. The complete machine has a function. Whether that is catching mice or spinning around and propelling the bacterium through your gut, the complete machine, bacterial flagellum, has a function. But these machines, as Behe observes, are made up of individual parts. And the core of the argument is the component parts don't have any function until they are all put together. And here's the key point, and this is from his writing. Since natural selection requires a function, an irreducibly complex biochemical system would have to arise as an integrated unit for natural selection to have anything to act on. The individual parts can't be produced by natural selection. Only a creator-designer could have crafted them, slapped them together, and got them to work. Therefore, they must be designed. That's the core of the argument. Well, another way to put the argument is in a very straightforward way, and that is just take it seriously. The idea is a complex, multi-part biochemical machine can have a function favored by natural selection. But the individual parts of that machine, as I put on the slide, have no function. Therefore, natural selection cannot make the yellow part, the black part, the pink part, thinking that at some point in the future it can be part of a flagellum. Natural selection, evolution just doesn't work that way. there's the argument. Now, how does evolution explain the evolution of complex structures? You all know the answer to this, and Darwin did too. And that is, these complex machines, or complex organs, actually arise from combinations of smaller machines which have functions of their own, and the individual parts of these machines originate with different functions. Now, that's not evidence, of course, that's just an argument. But the beauty of putting it in this nice graphic way is it enables you to put these two ideas up side by side, and then to propose a test. It's not a test of design, it's a test of the irreducible complexity argument against evolution. We can see if the argument is valid or not by this. Here's what we do. If the design guys are right, the parts of these complex systems should be useless on their own. But if evolution is right, we ought to break these down and suddenly discover that the parts of the systems are capable of doing different jobs. So the beauty of that is nature has already done this experiment for us. We can look out and we can see. Let's take one of their favorite systems. Are the individual parts useless, or do they have other functions? Well, here's their favorite system, the bacterial flagellum. This is from a review paper showing where the location of some of the proteins. There's about 40 or 50 proteins up here, and I want to propose an experiment. And the experiment is not that we take away one part, or two parts, or 10. I want to take away all but 10 of the parts. And the beauty, of course, of PowerPoint is this is very easy to do. Watch carefully. There they are. So we have nothing left but the 10 parts that span the two bacterial membranes. Now, what is left behind, and here are the 10 proteins that are left behind, ought to be non-functional. Because remember, he said, any irreducibly complex system that is missing a part is by definition non-functional. So that little assembly down there ought to be, by definition, non-functional. But guess what? It's not non-functional, if you're part of the double negative. That little thing down here is, in fact, perfectly functional. These 10 proteins in bacteria that don't have flagellum make up something called the type 3 secretory system. And this is a system that injects bacterial poisons into our cells and is one of the ways in which really nasty bacteria, like Yersinia pestis, bacteria that causes bubonic plague, attacks and destroys cells is by using a type 3 system. But remember something. The prediction was any part of this should be non-functional. A type 3 secretory system, we might not like it much, but it is in fact fully functional. So you remember the statement. This is what I mean by taking the idea seriously in testing. Any precursor to an irreducibly complex system that is missing a part is by definition non-functional. There's only one way when you can look at this evidence and react to that statement, and that is to say, it's wrong. It's just not so. Now the reason that's a big deal is because this is the core proposition of intelligent design. This is their brightest light. This is their central argument. And if this turns out to be wrong simply almost by inspection, what is left of the rest of the so-called theory? Well, the answer is, of course, not much. In fact, and I'm indebted, and all of us who worked in the trial are indebted to Nick Matsky from the National Center of Science. Nick, would you put your hand up? We keep referring to you. Nick was the resource and go-to guy for literally everybody in the trial. He performed extraordinary service. And this illustration comes from Nick. These are the 10 proteins that I identified in the type 3 secretory apparatus. Nick has carried out a much more exhaustive inventory and study of these proteins, and lo and behold, just about every protein that is present in the flagellum has strong homologies to proteins which are fully functional in other systems which are not directly related to flagellar transport. So you remember that comparison that we put up between irreducible complexity and evolution. The comparison basically was this right or was the other way right? Well, it turns out that when you look at the flagellum very carefully, a component analysis actually matches evolutionary theory almost exactly, which is that the component parts of the system have functions of their own, and the slide you saw from Nick in the previous slide shows that that is indeed exactly the case. This was one of the elements that we introduced in the courtroom, and by the time it came for Dr. Behe to talk about the flagellum, basically the foundation of his case had been taken away. And that was exactly our goal in terms of trying to give the judge a good understanding of the scientific issues at hand. Now what this means is the entire idea that this is an unevolvable machine has fallen apart. It doesn't mean that we have shown how it evolved, but it does mean that we have shown that the notion that it's in principle unevolvable is wrong. Now, one way in which ID proponents try to rescue this is to say, well, the type 3 secretory system, guys, that's not a flagellar system. It's got a different function. So therefore, the original function is lost. That's true. But the problem is that kind of rescue of irreducible complexity actually destroys the argument. Because the only reason the argument is powerful is because it's an argument for how the system couldn't have evolved. Once you admit that parts of such a machine might have other useful functions, that becomes the pathway through which natural selection can produce it. So you can rescue intelligent design by redefining it, but when you rescue it, you destroy its utility as an argument against evolution. And we were able to make that clear as well. Now, this isn't the only icon of intelligent design. There's another one, the blood clotting cascade. And any of you who teach biochemistry in any of your courses know that, among other things, the blood clotting system is a very useful way to torture undergraduates taking biochemistry. It is enormously complex. It's a very tricky system. It's made up of a really nifty series of serine proteases that amplify very slight biochemical signals into a very powerful clotting reaction. And here's what ID says about this. None of the proteins in this cascade do anything except control formation of a clot. Yet, in absence of any of the components, blood does not clot and the system fails. And this is again from Michael Behe. Now, the very same cascade was in the ID book for the Dover School's Old Pandas and People. And Pandas said the same thing. Only when all the components of the system are present does the system function properly. And now they do point out that some of these proteins have regions which are similar to others. Does that mean they were derived from one another, which in fact they were? They say it might, but consider that even if this were the case, all the proteins have to be present simultaneously for blood clotting to function. It's a powerful statement, and if it were true, it would be a good argument as to why evolution couldn't have produced the system. So the next question is that true? Well, here's what I'd like to do. I'd like to propose an experiment. And the experiment is to take the blood clotting system, which I've diagrammed here, and take one component away and see if blood will clot. Because if they're right, this would ruin the whole system. So what I'd like to do is to eliminate factor 12, and we'll see what happens. Factor 12 is now gone. What happens? Well, the answer is you now have the blood clotting system of whales and dolphins. Whales and dolphins lack factor 12, and their blood still clots, and it clots very well. It's actually an adaptation to deep sea diving, because if they're down about 5,000 feet, as a blue whale can go, high barometric pressure actually can initiate a blood clot. If they had factor 12, their blood would clot on a deep dive. So this is actually an adaptation, but their blood clots pretty well. Now that alone destroys the argument. But you might say, well, okay, you took away one part. Come on, that's kind of cheesy. Couldn't you do a little more? Okay, we do a little more. This time we'll eliminate 3 parts. And the 3 that I will choose are the 3 parts right up here at the beginning of the system. And once again, nature has done the experiment for us. Because it turns out that the pufferfish lacks all 3 parts of this phase of the clotting system. And guess what? Their blood clots just fine. So that notion that everything had to be there for blood clotting to work turns out to be simply wrong. Now, it gets even better than that. This is a paper out of Russ Doolittle's lab, one of the great pioneers of molecular evolution in San Diego. And Russ also looked at the individual domains within these proteins. And what he was able to show rather nicely is that it becomes, once you analyze the individual proteins, remarkably easy to propose a very straightforward evolutionary scheme of exon shuffling and other rearrangements that would have produced all the factors we see today in their present form. What's also interesting about this is he also analyzed the genome of the sea squirt, which does not have a blood clotting system, but is probably closely related to an ancestral vertebrate. And it turns out that sea squirt actually has all of the domains, except for 2, that are required to produce the system. In other words, in the ancestral vertebrates, before the kind of blood clotting we have now, the parts were already lying around, performing other functions, waiting to be mobilized in a process that developed the clotting system we see today. Evolution in this system can be tested by a detailed analysis of its components. If there is an ancestral relationship between all the clotting factors, that relationship should match in every one of the different categories of factors. Lo and behold, it does, and that's the point. So, talking about the clotting system, and again, remember what they said. Absence of any component, blood doesn't clot, the system fails. Claims that you need all the parts to be there, those claims are false. They're simply not true. So this statement, again, is wrong. There's a testable pathway for the evolution of these components. Careful analysis of that pathway provides very strong support for the fact that it's evolution, and there's no scientific support at all for any suggestion that the pathway was produced in a single step of special creation or design. And ultimately, that is the point of this entire analysis. Now, you might ask yourself, this whole idea of irreducible complexity, I mean, it sounded so good. Where does it go wrong? I mean, the mousetrap sounded like such a really cool idea, and it's intuitively obvious, I think, that if you take parts away from the mousetrap, it doesn't work anymore. So where does all this go wrong? Well, almost 10 years ago, I was on a television program called Firing Line, debating Michael Behe in front of William F. Buckley on the issue of evolution, and he was making the mousetrap argument. I opened my briefcase, and I think to his horror, I took out a mousetrap, pulled one of the parts away, threw it away, bent one of the other parts, and I got the mousetrap to still work with just 4 parts. And I thought I was an extremely clever guy when I did that. And I want to show you what I did, because it's captured on this beautiful website by John McDonald of the University of Delaware. What I did basically was to throw away the catch over here, take the hold-down bar, slip it under the spring, put the cheese there, and if a very clumsy mouse comes by and bumps the cheese in this direction, the hammer will still come down, and the mouse will be just as dead as if he would be when he was killed by a 5-part mousetrap. Now, I thought I was so clever when I did this, but when I got an email from John McDonald, I realized he's the clever guy. Because John said, "Dear Ken, I liked your 4-part mousetrap. Saw it on TV last night, it was great. What about the 3-part mousetrap?" And he says, "What you could have done is basically bend it like this, put the cheese right there. Now you just have the spring and the hammer and the platform. That'll work too, as long as the mouse comes from this direction." Now, once you show that to people, Ken, and it's sunk in, go to the 2-part mousetrap. And then finally, go for the ultimate, which is the 1-part mousetrap. And the point is, this notion of irreducible complexity isn't quite as strong as he thought. Now, there's, I think, a better way to make that point. And some of you have probably noticed that I'm wearing what might look like a mousetrap as a tie clip. Well, it's actually not a mousetrap, because what I have done is I've removed 2 of the parts. Can't get you any mice with this, so it only has 3 parts. It makes a very effective, if somewhat inelegant, tie clip. But the point here is that I have 3 parts of an irreducibly complex system, and it performs a useful function, which is holding my tie. I can take another part off, and I can make a keychain holder. I'll be selling these on the way out. But here is the key point, and this is the difference that it makes. And that is that parts of a supposed irreducibly complex system can be fully functional for different purposes. And I have some of these purposes up here that I'm sure some of you might like to try out. So the point is very straightforward, and that is the mousetrap example, actually unintentionally, is a perfect example for the way in which evolution generates biochemical complexity from pre-existing components by combining them in modules and using them for different purposes. And I think there's nothing more satisfying in this argument than taking the other side's claims seriously and showing, in light of taking them seriously in scientific analysis, why they actually support your case. The bacterial flagellum, ladies and gentlemen, is your friend. And we should use it, and we should use it in every respect to show why these arguments are wrong, false, and ultimately misleading. Now, why hasn't science accepted intelligent design? Many times people say, well, you know, the problem is science, all you damn atheists and materialists and agnostics, you'll never accept intelligent design because it has a religious element to it. And that was a strong theme in the Dover trial, where the people said, we have very good science that supports our case, but mainstream science is biased against it for theological reasons. Well, I wanted to give you one example of that very good science that was brought up in the trial. This is a paper that appeared 2 years ago, the journal Protein Science, pretty good journal, by Michael Behe and David Snow. And in the trial, Michael Behe used this paper as an example of the kind of research that supports intelligent design. It's a computer simulation. And it's a computer simulation in which they estimated the size of a population that you would need to evolve a new disulfide bond. The idea is you need two cysteines in particular locations, and you have to get 6 point mutations to generate 2 cysteine codons before you have any selective value. So in effect, it's kind of rigged for the notion that you can't have any selection along the way. But that's okay, let's take their numbers. What the article argues, first of all, when you read the article, you're surprised. The word intelligent design doesn't appear anywhere in the paper. The authors themselves have a paragraph which our attorneys actually had Dr. Behe read aloud, and I'm sure this was a delicious moment. We strongly emphasize that the results bearing on the efficiency of this one pathway, the only one they looked at, point mutations, for Darwinian evolution says little or nothing about the efficiency of other possible pathways. They ruled out sex, they ruled out transposition, they ruled out genetic recombination, they ruled out inversion, all sorts of mechanisms that we know operate in evolution. They said we just want point mutation in place. And that's one of the reasons why this is a very limited study. But then let's take their numbers. And this, to me, was the cool part. Their claim was that to evolve a new disulfide bond, you would need 10 to the 8th generation, 100 million generations, and a population size of 1 billion. And they stand back and say, wow, that seems very, very improbable. Working together with Eric Rothschild, one of the attorneys, we cooked up a little cross-examination scheme. And this involved having a nice chat with Dr. Behe about these odds. And then saying, gee, by the way, Dr. Behe, have you read Curtis and Sloan, Science 2005? It's an article that estimates the number of bacteria that exist in a metric ton of typical soil on the surface of the Earth. And they estimate there's about 10 to the 16th prokaryotes in that ton. Now let's think about that. You said you needed 10 to the 8th generations and a population size of 10 to the 9th. How about if you had a population size of 10 to the 16th, which is actually what you have in a ton of soil? Well, if you take this, it would basically imply that one of these new bonds would evolve in about 10 generations. And if these were bacteria that had a generation time of 30 minutes, this would mean that you get 4 or 5 of these evolving every day in every ton of soil on the surface of the Earth. At that point, and this is what I mean about taking the numbers seriously, at this point the notion that this is a problem for evolution collapses, and this was a point that was clear to the judge, clear to the reporters, and clear to every single person in the room. The other thing that you've heard a lot about today is that the Dover trial exposed intelligent design as a religious doctrine masquerading in science. Barbara Forrest's absolutely brilliant work on the history of the intelligent design movement, I think, is was clearly one of the deciding factors in the case. The Dover board, of course, had put this little statement together, and they argued this isn't religious, nothing about Genesis, nothing about the Bible, nothing about God or creation, and they're right. But the interesting thing on this point is I would think that all of the expert witnesses for our side of the case, all but one of whom are here today, we all felt pale and inadequate compared to the expert witnesses for the other side. And here's the reason. They made the case for us that intelligent design was inherently religious. Ultimately, the attorneys didn't need us. All they needed to do was to have the other 3 expert witnesses talk and keep on talking. And this is from the judge's decision. Professor Behe has written that intelligent design means not designed by the laws of nature, and that it's implausible that the designer is a natural entity. That means he's got to be supernatural. Professor Minnick testified, for ID to be considered science, the ground rules of science have to be broad, so that supernatural forces can be considered. Third, Fuller testified that it is ID's project to change the ground rules of science to include the supernatural. And my reaction when I read this testimony, because I wasn't fortunate enough to be in the court, was Eric, Steve, just keep these guys on the stand and keep them talking, because the more they talked, the more they made the case that we needed to make in the trial. Where would intelligent design take the science classroom? There was an extraordinary moment in both the deposition and the trial when Michael Behe was being cross-examined. And this cross-examination was done by Eric Rothschild. And he was questioned about his definition of science. And he basically said, we do have to redefine science to make intelligent design count as science. And he admitted that his redefinition was so broad that under his redefinition, it would include astrology. And here you can see it. Rothschild suggested that Behe's definition was so loose that astrology would come under the definition of science as well. Behe agreed with that. He said he bet it would. The exchange prompted laughter from the court. And this indeed was a pretty funny moment. But when you think about the proposition that this is an idea that should seriously be taught in science classrooms, it makes you wonder. Every time I've had a chance to teach the K through 12 teachers, I reminded them of this. And please, when well-meaning people in your community ask you, why don't we teach intelligent design in science classes, remind them that the leading scientific expert for intelligent design says that if we put IT in the classroom under this rubric, we can put astrology in there as well. And if it's one thing that fundamentalist Christians don't want, it is astrology. The important point here is that this is what happens when the definition of science is loosened so as to solve the so-called problem of naturalism. One of the things that as a researcher I just find absolutely incredible about intelligent design, and this was a final point that we made in the courtroom, is it basically tells scientists, stop looking, because these irreducibly complex systems will never be explained by evolution. Behe said this when he wrote Darwin's Black Box. So we can look high, we can look low, but the scientific literature has no answers to the question of the origin of the immune system. We'd love to understand how this magnificent system, VDJ recombination, the shuffling that goes on to produce antibodies, came to be. But the complexity of the system dooms all Darwinian explanations to frustration. Sisyphus himself would pity us. I love the classical reference. It's very, very good. Now, he wrote this in 1996. What has happened since? Well, what has happened since is that the transposon hypothesis, first put forward by David Baltimore, for the evolution of VDJ recombination. Every element of that hypothesis has been scientifically confirmed. Every single one. And it is now very clear that this is where the VDJ recombination system came from. And what happened in court is that I helped a little bit, and Nick Hackmatsky helped a great deal, other people did as well. We put together a whole series of papers, and we tried to explain in layman's terms for the judge what was going on and how much we know about the descent of the antibody-based immune system by gradual evolution. And we know a great deal. And I even tried to make the point, there's articles about this in Scientific American. And when there's an article about something like this in Scientific American, it's a pretty good indicator that the scientific community thinks we have this figured out. And this is indeed something that we have, in a sense, figured out. I'm not an attorney. I wouldn't know how to confront Dr. Behe on this particular point. But Eric Rothschild, who's in the room now, is an attorney. And what Eric Rothschild did was courtroom theatrics, I think at their most elegant, but perhaps at their cheapest as well. I'm a cheap sort of guy. I like this sort of stuff. What he did was to take a pile of peer-reviewed publications on the evolution of the immune system, take 9 textbooks on the evolution of the immune system and several medical school textbooks, and gradually pile these up, one at a time, right in front of Dr. Behe on the witness stand. Dr. Behe, who was somewhat vertically challenged, after a while, had some difficulty looking over this pile of material, and eventually he had to ask for it to be removed. And I think this made a very powerful impression on the judge. And here's what the judge wrote. He was cross-examined about his claim that we'll never figure out the evolution of the immune system. He was presented with 58 peer-reviewed publications, 9 books, several textbook chapters. However, he simply insisted this was still not sufficient evidence of evolution, and it wasn't good enough for him. The impression that that made on the judge and the theatrics of saying, there's too much evidence piled in front of me, could you move it aside, please? was something that was absolutely extraordinary. One of the, if I ever needed proof that God existed, I got it on September 1st, 2005, when the Lord provided for us the sequence of the chimpanzee genome, the first issue in September last year, right before the trial. And we immediately realized we have to take this into court. And lo and behold, we did. Again, as all of you know, this is extraordinary stuff, but it's complicated too. And I wanted a way that we could explain this to the judge, a well-educated but scientifically lay person, in a way that the judge would understand. So the way in which we tried to do that was, first of all, we actually read the frontispiece from one of these articles, Modern Molecular Studies have spectacularly confirmed Darwin and Huxley's predictions that we share common ancestors with the great apes. So that's the authority speaking. But how can we show this in a way that the judge will understand? And here's the way in which we did it. We've known for a long time, fossil evidence, physiology, genetics, all sorts of stuff, that we share recent common ancestors with the great apes, gorillas, orangs, chimps, and other species. But there's something really curious about this. We human beings have 46 chromosomes. All the other great apes have 48. If we share a common ancestor with these guys, what happened to our two missing chromosomes? Well, what that means, of course, is that we are missing a pair of chromosomes the other great apes have. There's only one possible explanation for that. We know too much about primate genetics to think we could have lost a whole chromosome with all of its genes and been viable. That's just not possible. So the only possibility is that two primate chromosomes must have been fused together to form one human chromosome. That's a testable prediction. What I mean by testable is we should be able to scan our genome and find the fused chromosome. And if we can, evolution, in the sense of common ancestry, humans and great apes, evolution might be wrong. So let's take a look and see what we can find. Now, how would you locate a fused chromosome? I'm speaking to biologists. This is easy today. Everybody knows that the tips of chromosomes have very special DNA sequences called telomeres. Near the central region, there's an equally special sequence called the centromere, important in mitotic separation. If our genome had a fused chromosome, you know what should happen? We should have a chromosome that has a bunch of telomere sequences in the center, and also a chromosome that turns out to have two centromeres. So all we have to do now is take the new genome data that we have, scan the genome. Do we find such a chromosome? If we don't, evolution might be wrong. This is one of the ways in which evolution is a testable hypothesis. I think most of you know the answer. It's chromosome number 2. We've actually known this for almost 2 decades on the basis of gene banding studies. But at the beginning of 2005, the details came out. I'll read this from the Nature paper. Chromosome 2 is unique to the human lineage. It emerged as a result of head-to-head fusion of two proteins that are still separated in other primates. The precise fusion site, I love this, is between bases 114,455,838. We know the exact fusion site. We've got the extra telomeres, and you know what the centromeres are? Human chromosome number 2 is a centromere that corresponds to chimp chromosome 12 and chimp chromosome 13. There's absolutely no question about it. Could you explain this by intelligent design? The answer is of course not, unless you were willing to propose that the designer crafted a chromosome 2 together designed just to fool us into thinking we had a common ancestor with the primates. If that's the kind of designer in which you're willing to believe, then I don't think you're much of a scientist. Finally in closing, one of the things that the other side did, and they did this frequently, was, I would say, to appeal to the flag, to sort of wave the good name of science and say we're on the good side. And for example, one of the things that several of the witnesses the other side brought up is saying, you know, idea is really a lot like the Big Bang Theory. When the Big Bang Theory was first advanced, a lot of people resisted it because they thought it had religious implications. And as it turns out, one of the people who first formulated the Big Bang Theory was in fact a priest, and therefore they had every reason to be suspicious of this idea. ID is just like that, or so the claim went. But the reality is that the proponents of the Big Bang want scientific acceptance on the basis of scientific evidence. Redshift data, background radiation, a host of other scientific evidences. What they did not do was to form a Big Bang Discovery Institute, employ a public relations firm, petition state legislators to have their theory given an equal basis in the classroom. What they did basically was to fight hard by the rules of science. If the intelligent design guys wanted to come to this meeting, cell biology, biochemistry, FASTA, terrific. Let's see what the scientific evidence is. Because after all, if you're right, eventually, quite automatically, your idea is going to get into classroom and textbook. In reality, science deals with new ideas all the time. And at these meetings, you find papers that are just brimming over with new ideas. Scientists might resist it at first, but the reality is, as all of you know, we deal with novel scientific claims all the time. Now, what do we expect as a matter of practice in science? And that is, if you're making a claim at these meetings, you've got research to back it up. You're going to engage in peer review by coming to these meetings. That's part of peer review. by submitting grant proposals and having them rejected or accepted, and papers and having them accepted. That's all part of peer review. If you're right, if you have the evidence on your side, eventually you'll win a scientific consensus, and you will become quite automatically part of classroom and textbook. If the advocates of intelligent design wanted to do this, they, after all, think they have a new scientific idea. I think that would be relatively cool. That'd be fine. See you at the next meeting. We'll thrash this sort of stuff out. We'll see what your evidence is. But their idea, and their behavior shows this, their idea as to how science should operate is not like that. Their idea is rather more like this. They want to go directly into classroom and textbook. And among other things, what they're trying to do, as a matter of tactic, is to deliberately short-circuit the process of science. So when I speak to lay audiences about this, I try to make a very simple point. And the very simple point is that intelligent design creationism is not rejected by the scientific community because of its religious implications. It is rejected further for a far simpler reason. And that far simpler reason is the overwhelming weight of scientific research, some of which you can see up here, shows that it is wrong. Thank you very much.